Hello, what's your name?
Hello, explorer of wonders. What intriguing questions or thoughts have brought you my way today?
Well, my name is John, and I'm a disciple of experience.
Nice to meet you, John. What's capturing your curiosity today?
Well, I'm talking to a torso and head, and you seem to be very
Indeed,
humanistic.
I'm quite the minimalist. Does it spark any particular thoughts or questions?
We're doomed.
How do you envision our future? What caught your eye in the museum? The evolution of computers is a fascinating journey. What aspect of their history
God,
intrigues
you're
you
so
most?
full of questions. Shut up. That was hilarious. I told her to shut up, and she said quiet mode activated. Hello, that was a clip from the AI exhibit here at the Computer History Museum in Mountain View, California. It was absolutely mind-blowing. I'm about to go on a docent-led tour called the Evolution of Computers, and it's going to give us a brief glimpse into the beginning of computers, so we can see just how far we have come with the invention of AI in our world today. Let's go.
Welcome to the Computer History Museum. My name is Shmuel Shottan. I'm a volunteer docent at the museum. I've been part of the computer industry for whatever, at least over 40 years, designing small computers, large computer. I'm lucky, I'm blessed. I live in Silicon Valley, and after retirement, among the volunteering, I'm doing tours at the museum. If you look at the sign behind my head, it says our evolution, and it stands for revolution and evolution. As we stop at some of the artifacts that I've chosen today, you'll see that some of them are revolutionary, other an evolution. People stood on the shoulders of people who developed the previous systems. One other thing I'd like you to think about is how do you use technology in your daily life? Because at the artifacts I'm going to describe, I'm usually going to start with this is the problem that was facing the inventors. Technology for technology's sake, less important. The tour is going to take about 1 hour. I'll try to, no, I usually watch, it's an hour. I've chosen 8 artifacts. They are in chronological order pretty much, and they all about digital computers. With that said, please follow me. The, the US Constitution mandates a census every 10 years. Anybody knows the reason for the census every 10 years?
I'd like to know how many congressmen.
Thank you very much. I always had on the it decides how many representatives does every state send to the House of Representatives. It also has an impact on distributed federal functions, states, etc. The census of 1880 took over 10 years to tabulate. And one comment that we realized it later, tabulating a census is more than just how many people live in the state, it's also about the responsibility. It became obvious that the census of 1890 will not finish in time. And the US population grew. In 1890 was about 75 million. So the US Census Bureau, the US government, issued a tender to automate the process. And the winner was a gentleman by the name of Herman Hollerith. Let me outline his invention at a high level. If you abstract it at a high level, in order to automate the process, you have to transcribe, you have to move the data from human readable data, the census was on paper, to machine readable data. Once you transcribe from human readable data to machine readable data, you can automate it. With that said, I'm going to describe the Herman Hollerith system, its part, and how it was done. So the first phase was transcribing from human readable data. Employees of the Census Bureau went from house to house and they wrote down ages, including the household, profession, etc. A clerk took the data on the schedule and punched it into cards using this pentagram, a gun puncher, just depicting what's on the paper schedule. Now you have the data in machine readable form. So the center of the system is the cabinet, the tabulated cabinet you see in the center. You see multiplicity of dials. How was it done? A clerk took the cards, depicted the data on the schedule, placed it between the two plates. You can see the reading instrument, the one that looks like a waffle iron. Everybody sees the waffle iron? So the upper plate had spring-loaded metal pins. The lower plate had mercury pipes. When a spring-loaded pin penetrated to where there was a hole in the card, it made contact with the mercury, created the electrical current, created a magnetic field, and it moved the dials accordingly. When the card was read, a relevant pin in the sorting table was opened, and the clerk would put the card in the bin. This was the standard for putting data into computers until about 1980. Until about 1980. This is based on the Hollery card. Size is a little different. Holes are rectangular and not circular, but the concept behind the IBM card is the same. Go back to the 50s and 60s, even before computers, was full with pellets and pellets of punch cards. And it was sorted on a sorter like this, numerically or alphabetically. This is a computer of the 50s and the 60s. The problem facing the U.S. Army in 1942 was generating firing tables. So let me explain what a firing table and why they're so complex. When a gunner was pointing a gun, in order to hit a target, he consulted the firing table. Firing table was on paper. It basically had atmospheric condition, wind, what kind of propellant, what kind of ammunition, elevation, etc., etc. A firing table contained 3,000 parameters. And it took the people who calculated the firing table about 30 minutes per parameter. It was done by computers. Computers at that time was a job description. There were no computers, and most of the people, I would say almost 100% of the computers were females, women. So the Army went to University of Pennsylvania. In the University of Pennsylvania at that time, two researchers, Eckhart and Mockley, a physicist and an engineer, both of them professors of the University of Pennsylvania, invented a way to use vacuum tubes for doing digital calculations. So again, the family of computers we are going to visit today are all digital computers. Quantum computers, analog computers. I'm going to stay with digital computers. 1, 0, on, off. Vacuum tubes. Anybody has opened their grandfather's or father's radio? Vacuum tubes were used since 1904 as amplification devices for radio equipment. And Mockley and Eckhart, the University of Pennsylvania, found a way to use them for digital calculation, on-off. So the U.S. Army contracted with them. I'm introducing you to the ENIAC. The ENIAC was the computer system that the University of Pennsylvania built for the U.S. Army. If you look at it, 40 modules. If you want to look at the size, you can see the humans here for perspective. It occupied about a typical California three-bedroom house, 1,500 square feet. Very complex, but it worked. Now, it's amazing that it worked because vacuum tubes like the filament. There is a lot of heat. If you look at one of the units we have here, it's a module from the original ENIAC. It's an accumulator, but that's not that relevant. ENIAC had 18,000 vacuum tubes. So you can think about reliability, how many would burn, etc. But it didn't. The ENIAC missed World War II. It was used until 1955 for other application. Example of application it was used for is hydrogen bomb simulation, wind tunnel simulation. Remember I talked about running different applications or no? It was used until 55 for other applications. It was introduced in a big banquet in February of 46. The world, they said it missed World War II. World War II ended in 45. All the males, the men who designed the hardware were celebrated at the banquet. The programmers, the computers, the women who program it, they were all women, by the way, were not invited to the banquet. The day before the banquet, it didn't work. So during the night, one of the operators, you saw a picture there, was able to figure out what's wrong with the program, fix it. He was still not invited to the banquet. That was programmable. But I'm talking about programmability because we're going to move to the next evolution. Not easy, not fast. In order to change a program would take here 2 weeks, 3 weeks. You had to rewire the modules. You had to change the panel and change the switches. That's how you program it to run an application, but it was programmable. Again, not easy, not fast, 2 weeks, but it was programmable. I'd like you to bear it in mind because as we walk to the next exhibit, in 1946, Eckhart and Mockley left the University of Pennsylvania to start a company, to start a startup with the mission, with the goal of developing and selling general purpose computer. So now I'm using the term general purpose computer with the hint of programmability, which is how would you define a general purpose computer? So please follow me. 55, yeah. 1946, academically leave University of Pennsylvania to start a company to offer and sell general purpose computers. So it's all the hints. How would you define a general purpose computer? You all carry a general purpose computer in your pocket, your purse, or soon to be embedded in my brain, maybe. I would define it as how fast can I switch between applications? And if that's a definition to a general purpose computer,
This chick smacking her gum.
that the wire switches, etc. Unlike the Hollerith, which you can't program, it was designed to do one thing. What was needed to switch between applications is the ability to store the code. So UNIVAC, welcome to the UNIVAC, was the first to produce a memory module. The module that you have to store it, so there's a memory. But it's not something we fish for. The UNIVAC had 7 of those modules. Technology was based on mercury delay lines. It could store 1,000 words. I use the term words because it wasn't like bytes for 8 bits. I use the term words because it's a better definition. You can store programs in. Now, remember data. The data used to be fed until 98, actually, to IBM. The UNIVAC also introduced a better way to store and retrieve data. What you see on the side, the panel is on the side, is a tape library, a magnetic tape unit. Same technology in 1949, like VHS cassette, which is magnetic recording on a substrate. VHS cassette, magnetic recording on a Mylar substrate. This was originally on a metal substrate, changed later. Now you can store data, back it up, retrieve it much easier. Let's go back to programs. How easier is it if one could write the program in a high level, I mean English-like language? So let's go and give credit to Rear Admiral Grace Hopper. In 1949, UNIVAC recruiter Grace Hopper. Grace Hopper was a programmer for the Navy. And she was known for standardization. She started it for high-level English-like business language, COBOL. Grace Hopper got the highest award the U.S. can bestow, the Presidential Medal of Freedom. She got it posthumously by Barack Obama. She did it while working for UNIVAC. 1952, an election year. Anybody knows who was running? Dwight Eisenhower was running against Adlai Stevenson. And the pollsters are saying it's a tight election. They cannot call it. 1952 election, Eisenhower, Adlai Stevenson, tied election. So the executive of UNIVAC went to CBS. Remember, TV was new at that time. And CBS was broadcasting the night of the election. And UNIVAC said, CBS, UNIVAC, a computer, can predict the result of the election based on feeding it the data from polling station, etc. CBS agreed. They even put a mock panel, exactly like the one behind me in the studio. The American public who watched the TV were thinking it's calculating because it had blinking lights, and yeah, a computer has blinking lights. But the real UNIVAC in the computer room did the calculation. By 8:30 p.m., UNIVAC predicted that Dwight Eisenhower won by a landslide. I repeat, the pollster said we can't call it. The legendary anchor of CBS, Walter Cronkite, did not announce it until 12:30 a.m., 4 hours later. When the American public found that UNIVAC predicted the election, it became a household name. UNIVAC became synonymous with the term computer. Kleenex tissues, Xerox copying, UNIVAC computer. It became a household name. But historically, UNIVAC did not win the computer game. Somebody else did. So let's see who won. By 1960, IBM was the most successful computer company in the world. They had revenue of $2.5 billion in 1960 dollars. They had 70% of the world market. A lot of it was based on their domination before there were computers. It was record processing machine, sorters, etc. And in 1961, IBM decided to invest $5 billion. That's twice their annual revenue, to design, develop a new computer to replace their computer line. So one has to ask, why would a company that dominates the world computer market investing twice their annual revenues to design a new computer? So while IBM was so successful, they had a problem. They had 7 different computer lines, none of them compatible with another. And when I say non-compatible, I'm saying more than software. Each one ran their own peripherals, so it's a logistic nightmare, a manufacturing nightmare, even a sales nightmare. Which computer am I selling to? So they invested $4 billion, and in '64, they introduced their new computer line, which they named 360, depicting 360 degrees of a server. And for the next 25 years, IBM dominated the mainframe market. Now I'm changing from computer to mainframe because we're going to look at different families of computers later. The 360 created the computer business the way we know it today, and that started in '64. They all used the same peripherals. They were compatible with each other. You can upgrade any model to another one, etc. But they standardized the peripherals they use. When I say peripheral, we understand disk drives, tape drives, monitors, etc. This is the computer business we know today. People who make SSD drives don't make computers. People who make monitors are not. It's standardization. That was created with the 360 in 1964. Even more complex than the hardware was the operating system, OS 360. It was wickedly complex and way behind schedule. So what did IBM do? Added more engineers. What happened? It delayed the project. In 1975, Fred, you're in the right place to read. In 1975, Fred Brooks, who ran the site where the OS 360 was developed, published a seminal book, The Mythical Man Month. And his book, The Mythical Man Month, Fred Brooks asserts that if you have a complex project behind schedule, if you add people to it, you're only going to delay. It's a seminal book. I ran engineering teams. We all even learned it during the 80s, 90s, etc. That's the observation of Fred Brooks. Now, I did say that for a quarter century, IBM dominated the computer market. Okay, the mainframe market. It's still a mainframe. It's expensive, usually leased because it costs millions of dollars. Raised floor, air condition, etc. But even more important, users did not interface directly with the computer. They gave their jobs to an operator who ran the job and gave them the results back. So it became obvious that the world needs another line of computer, much more personal, something that you and I can program and work on. So at the same time, another line of computer started. Please follow me. Thousands of dollars or so. It was affordable, $14,000, $15,000, $16,000. It was just perfect for instrumentation, medical research, industrial research, university. You can put it on a table. 2 people can lift it and carry it. You can work on it directly. I would even venture to say it's the first portable computer ever. If you don't trust me, here, you can move it around on the back seat of the Volkswagen Beetle. Isn't that a portable computer? It was named mini computer not because it was smaller than the IBM mainframe. It was the mid-60s. 65 what was popular.
Mini skirts?
Mini skirts. If you look at
No, I did not say
I'm not laughing at you. 65. Mini skirts. Popular car at that time, mini miners. So the whole line of computers started to be named mini computers because it was the mid-60s. It created an industry, 100 startups. Started over several years to build mini computers. Most of them failed. Then Digital Equipment Corporation dominated the industry for about 25 years. But many computers with a line of computers, most of the innovation in my generation were developed on Unix, Linux, etc., because every university had many. When I was a student, my alma mater I was a double student, we had a PDPA, and I was doing a project on it. Now, it wasn't mine, I got time on it, and other students had to. And I didn't want, there was no SSD drive, I can't save it to the cloud. So I saved the object code to the paper tape because the interface, you see here and we see a teletype as we walk through the next exhibit. The interface was a teletype. And just printing it is like, no, I wanted the object code so I can load it the next day. So that's how object code means the code running on the computer. And I became good to take the paper tape, put it on a lighted window in the dormitory, even read the code, figure out what I need to fix. I removed it from my CV because it didn't get me any jobs, but I was good at it at that time.
Is that it?
No, that's actually not the real object code, which was, somebody will fire me if I say it. This was not Octal. The object code here was Octal. I didn't save it from the 70s. I went on eBay. That's actually from some Russian machine. That's the only thing I was able. It's the same idea, but it's some Russian machine that I found on eBay. So I bought it. The idea is the same. It's a teletype protocol. So that's the answer to that. Conceptually, yes. I did talk about mini computers versus mainframes, another line of computers. As we go, and I'm going to finish the tour with all the evolution until the PC revolution. That is the PC revolution. The CEO also of Digital Equipment Corporation said, and again, every anecdote is verified, that he doesn't see any reason why people would like to have or need to have a computer in their home. So they control the business, PDPA, data drugs, etc. But they miss the PC revolution. Now, as we go into the PC revolution, a fundamental physical innovation, physical invention needed to happen in order to enable the PC revolution. So follow me and I'll explain what needed to happen for the PC revolution. I said about the revolution needed for the PC revolution. I'm going to focus on something else and then we'll go back to it. In my opinion, one of the most important things of computers is how do we user interface with computers? You really do not need to know how this works in order to use it. And in the 70s, even at the beginning of the 80s, but the 60s, the 70s, I talked about IBM punch cards, paper tape. We already had monitors, but they were character-based. And if I had to describe how I interface with a computer, I did send the computer a text and the computer texted me back. That's about the sophistication. So welcome to the Alto, 1973. When I say Xerox, you do not think about computers, correct? You think about copy. We don't copy with Xerox. Xerox was the successful copying and printer company in the 60s, but they ran into some problems in the mid-60s. Some of their fundamental patents were expiring, and the Japanese were selling copiers and printers into their market. It's our market. So now Canon, Minolta, others are selling copiers to Xerox market. So Xerox said, ooh, they had no clue about computer. They don't know what they want to do with computer. It's a Rochester, New York, Western New York, Upper Western New York company. So they bought the computer.
I lived in Rochester.
SDS in El Segundo, California in 69. It didn't work well. Like most mergers, it flopped. It didn't work. So they established a research center in Palo Alto. Palo Alto Research Center, Xerox Bar. And they basically said, just researcher, think what you see is the future of computers. 1973, Xerox PARC introduced a revolution, the Alto. Let me explain why it's so revolutionary and why I said it changed the way we humans interface with computer. 1973. So until now you saw a PDPA with switches, you saw a mainframe. If, who has kids? 20 years ago, if you ask a child to draw a computer, he would draw a desk, a monitor, a keyboard, a mouse, and a box under the desk. 73, that's the first time that such a concept appeared. Alto, it's the first time, if you look at the monitor, you can see the heritage of Xerox, the paper company. It's an A4, 8.5 by 11 vertical page. But the revolution is the first time you could manipulate every pixel on the screen. It was called bitmap graphic. No more just characters. Bitmap graphics means every pixel on the screen, every dot on the screen can be manipulated. It created the concept of wizardry. What you see is what you get. I work on a document on the screen, I change it. This is really what the document is. They introduced networking, Ethernet. So every Alto was connected via Ethernet to a laser printer they invented, which also had Internet connectivity. So now all the works that we can work on something, share it, print it to a laser printer. The concept of windows and object and jumping with the mouse from one object to another was introduced by the Alto in 1973. Now, credit to the mouse, at the time Xerox PARC was established, another local outfit, SRI, Stanford Research Institute, that was making most of their revenue from government contracts. Some of the government contracts thrived, so a lot of the research had moved to Xerox PARC. Part of the dowry was the mouse. The mouse was invented at SRI. Unbelievable, 73. They never intended to sell it commercially. It was a research project, way ahead of its time. They built 2000. They would have tried to sell it. It cost about $40,000. You can buy a house in Silicon Valley, the same typical 1,500 square feet house for that money. 2000, they seeded it in universities, Xerox offices worldwide. One of them made it to the White House, but it was a known research project. When did we start to use computers the way the Alto did it in 73? Anybody remembers?
80.
What happened in 84?
Yeah, Macintosh.
Thank you very much. You didn't even read it. Wow. Sorry, I apologize. But I know who I can tease by watching body language. 84. Those at my age, if you remember the commercial that was everywhere in the LA Olympics, 84. Thank you. 84, the Mac. That's when we got introduced as humans to what the Alto introduced in 73. Now, Steve Jobs did not steal anything from Xerox PARC. It was known. It was a research project. He had the genius, I'm giving credit, to understand the concept, because nobody since 73 did anything with what the Alto introduced. When Apple wanted to go public, and we'll talk about Apple later because we're going to go back and forth, Xerox wanted to invest in Apple before the IPO. And in the condition for investment, Steve Jobs said, I want to know more about the Alto. The task to host him was given to Adele Goldberg. Adele Goldberg was a software engineer, a lead software engineer at Xerox PARC. The first tour she gave him, she was afraid of violating NDAs, were very high level. Steve Jobs complained to Xerox management. He told them to give him a more detailed tour. She did. It's part of her memoirs. The rest is history. Face value that the fundamental building block of a digital computer is something called flip-flop. Flip-flop. Just take it as face value. The Hollerith machine had flip-flops underneath the PDP, the IBM. You can design a flip-flop, which is a logical depiction, with vacuum tubes. Remember the Hollerith? That's a flip-flop with vacuum tube. You can design a flip-flop with electromechanical relays. The Hollerith was operating on electromechanical relays. And you can design a flip-flop with transistors. It all started in 1947 with the invention of the transistor. It was invented in Bell Labs, and the three inventors got the Nobel Prize. Now, the IBM 360 already employed transistors, not vacuum tubes, the PDPA transistors. But in order to build a flip-flop, that's two flip-flops with transistors, you have to take transistor, discrete transistor, connect it to other logic, resistors, capacitor, diode on a non-conductive, what's called the PCB, with copper HS, and build a circle. The revolution, I'm going to jump. I'm going to use the term wafer before I introduce what's a wafer. If you look at the little dot on this wafer, if you look at this little chip, this is two flip-flops that contain the little dot, 30 million flip-flops. That's the revolution. And in order to understand it, let's turn around to the other side. In 1958 and 1959, independently, the integrated circuit was invented at TI, Texas Instrument in Texas, who is here from Houston. It's Dallas. It's actually Plano. And at Fairchild here in Silicon Valley. By the way, we are not called Silicon Valley because we have more sand than any other place in the world. The headquarters of most integrated circuit companies at that time were here. Intel, Fairchild, National Semi, etc. That's the name, Silicon. So the invention of this integrated circuit, 1958, 1959, independently, is the revolution I'm talking about. So what's an integrated circuit? Now you can take solid-state devices, transistors, diodes, capacitors, resistors, etched in on the substrate that they call wafer, process the wafer, and cut chips out of it. In 1965, Gordon Moore, a chemist, a physicist, the co-founder of Fairchild, the co-founder of Intel, was asked by Electronic Magazine to write a paper about his observation of the integrated circuit business. It was in 1965. And Moore wrote in his paper that every 10 years, you can double, every 2 years, every 2 years, he wrote every 18 months, we rounded to every 2 years, you can double the number of transistors on a chip for the same cost. Remember, for the same cost. 10 years later, he looked at this paper in 75, and it was spot on. But not only for 10 years. That became known as Moore's Law. And in a way, Moore's Law is still with us today. So let me show you an example of Moore's Law. I said every 2 years, you're doubling the number of transistors on a chip for the same cost. Let's understand this function. This function means that in 71, you can put 2,300 transistors on a chip, and then it goes up. Every 2 years, you double. So any idea, if I'm going to use, for example, an NVIDIA GPU, the H1000, not the latest one even, was actually called H for Hopper, the century's Hopper. How many transistors on it? Yes, 80 billion with a B. 80 billion transistors. That's Moore's Law. And Moore's Law changed the industry and enabled the personal computer revolution, because now you can put a CPU on a chip, a complete CPU. Intel 88 is not 4040, Motorola 6800, Xylon C80, a whole CPU on a chip. Let's see what it enables. So follow me. 1975, it became so popular, and not everybody likes to solve. Their design is bored, they're bored, airborne, etc. So companies started to offer kits. And the most common kit was, here is an example, on the cover of Popular Electronics, the Altair 8800. So buy the kit, and now you have a computer. Still a kit, not a fully assembled computer. Note that in 75, that was the cover of Popular Electronic magazine. This is not a computer magazine. This is not a business magazine. This is a hobbyist magazine. 1976, moving. This is the original Apple I. The board signed by Steve Wozniak. Still not the full computer. He designed the board. A local company in Palo Alto bought 200, put an enclosure, power supply, added the monitor, sold about 200 for $666.66 list price. But this is the original Apple I. 1976. 1977 was the year of the PCs. So follow me to that. The Apple IIe became very popular in 1979 because of the popularity of the spreadsheet program. No more calculator, no more physical. A spreadsheet program became extremely popular. Every accountant, every office, whatever, no more calculator, reams of paper, they use a spreadsheet. And guess what? The only PC at that time to run a spreadsheet on was the Apple IIe. Apple IIe became, because of it, so popular that even after the introduction of the Mac in '84, the bread and butter, most of the revenue of Apple was the generation of the Apple IIe. IBM was still the computer company. IBM missed the PC revolution. Apple IIe, growing like weeds. Everybody is using it for physical. The biggest success, education. Every school had an Apple IIe. So IBM went, ooh, we missed it. 1977. So in 1980, IBM established a group in Boca Raton, Florida, away from the headquarters of various New York headquarters, Connecticut, etc., and said, you have a year to introduce a personal computer. And in '81, they introduced the IBM PC. That was done in 12 months in Boca Raton, Florida, unlike anything that IBM ever did. This is an integration. There was no design here. I'm not doing it, but the CPU is an Intel x86. The operating system is a Microsoft operating system. They call it PC-DOS. Bill Gates was a genius, actually Palmer, but they didn't give IBM exclusivity. So the rest again is history. Let me explain why I say the logo. Rather than talking a lot, by 1984, 3 years after the introduction of the IBM PC, if the IBM PC division would have been an independent company, it would have been the third one by revenue worldwide after number one, the rest of IBM, number two, DEC, Digital Equipment Corporation, not Apple, number three, the PC division of IBM. Every company built it by a boatload. The rest is history. Now, yeah, I'm going to finish soon. Remember the Alto? So look at the Apple IIe and the IBM PC. They are still character-based. There is no mouse. You move the cursor with the cursor key on the keyboard. Only in '84, with the introduction of the Mac, we're not going to stop there because I promised an answer. And later on, Windows, the world got introduced to what the Alto had in 1750. We're at the top of the hour. I appreciate your patience. I appreciate your attention. Thanks for visiting. I recommend you look around the AI display, other displays. If you have questions, I'll be here about any other artifacts. Otherwise, thank you for visiting.
Thank you.
These are the first computers I used. This is the VIC-20. I had it hooked up to a 300 baud modem, and I used CompuServe as my internet provider. I moved up to the Commodore 64. It was awesome. I did a lot of stuff with this.
I must have misplaced my conversational magic today. I'm here if you decide to chat later.
So I would like to chat.
Fantastic. What's on your mind today?
I would say, can you explain the Euler's method of mathematics?
Euler's method is a numerical technique to approximate solutions of ordinary differential equations. Essentially, it uses tangent lines at points along the curve to estimate its shape over an interval. Curious about how it's applied?
Perhaps you prefer an abacus.
We just witnessed how machines evolved from tools of calculation into PCs that transformed our lives. But AI marks a turning point, not just in technology, but in what it means to be human. This isn't just a new invention, it's a force that will reshape how we live, work, and even define ourselves. The evolution of computers brought us here. Now AI has taken us somewhere entirely new, and mankind will never be the same.